Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to second solved problem. The problem is without expanding the determinant, show that determinant b plus c plus a plus b, c plus a plus b, b plus c, a plus b, b plus c plus a is equal to 2 times determinant A B C B C A C A B. This is the our second solved problem. In this problem, we have to given that without expanding the determinant by using LHS, we have to determine the RHS value, but this determinant is not expanding for proving this solution. ఈ ప్రాబ్లంలోని ఎల్హెచ్ఎస్ వాల్యూలోని డిటర్మినెంట్ వాల్యూని ఎక్స్పాండ్ చేయకోకుండా సెకండ్ ఆర్హెచ్ఎస్ వాల్యూని డిటర్మినెంట్ని రాబట్టాలి అనమాట. ఫర్ దట్ ఫస్ట్ వీ హ్యావ్ టు టేక్ ఎల్హెచ్ఎస్ వాల్యూ, దెన్ సొల్యూషన్ LHS value. LHS equal to determinant B plus C, C plus A plus B, C plus A plus B, B plus C. Third row A plus B, B plus C, C plus A. This is the given determinant value, but for solving the RHS, we are not expanding the determinant value, but we have to determine the RHS value. For that, we have to use some operations. Here we have to use first operation is R1 is going to be R1 plus R2 plus R3. The first row can be turned into R1 plus R2 plus R3. That is equal to modulus R1 is going to be R1 plus R2 plus R3. That means B plus C plus C plus A plus A plus B. Here we have 2A, 2B, 2C. By adding the values 2A plus 2B plus 2C. Similarly, the second element are also same, 2A plus 2B plus 2C. And the third element also same, 2A plus 2B plus 2C. Here C plus A plus B, B plus C, A plus B, B plus C, C plus A. This is the first operation. In that in first row we have to take 2 as common, then that is equal to determinant 2 into A plus B plus C, 2 into A plus B plus C, here 2 into A plus B plus C, C plus A plus B, B plus C, A plus B, B plus C, C plus A. Determinant. In first row, we have to common 2, because 2 into A plus B plus C is also common, but we don't take A plus B plus C as common. We have to only take the 2 as common. That is equal to 2 determinant A plus B plus C, A plus B plus C, A plus B plus C, C plus A plus B, B plus C, A plus B, B plus C, C plus A. This is the determinant value. In this, we have to take some more operations, that are R2 is going to be R2 minus R1. and also R3 is going to be R3 minus R1, that is equal to 2 into modulus. First row is same, a plus b plus c, a plus b plus c, here a plus b plus c. R2 is going to be R2 minus R1. R2 is C plus A. Minus of R1 means A plus B plus C. That means C plus A minus B minus C. Here minus A minus C plus A plus C plus C plus A cancel. Then the remaining value is minus B. Here also AB minus AB get cancelled, minus C minus A. Similarly here minus C minus A minus B. After applying the operation, R2 is going to be R2 minus R1 and R3 is going to be R3 minus R1. The value is that here we have to take in second row minus into common, in third row also minus get common, then that is equal to 2 into minus 1 into minus 1. In second row minus 1 get common, in third row also minus 1 get common, then the remaining determinant value modulus a plus b plus c, a plus b plus c, a plus b plus c. Next, the remaining value is B, C, A, C, A, B. Then that is equal to 2 into minus 1 into minus 1, 2. Determinant A plus B plus C, A plus B plus C, A plus B plus C, B, C, A, C, A, B. But in first row we get by using the by solving the RHS ABCRs. Then for that we have to take one more operation. R1 is going to be R1 minus R2 minus R3. That is equal to 2 into determinant. R1 is going to be R1 minus R2 minus R3. R1 is A plus B plus C minus R2 minus B minus R3 minus C. Plus B minus B plus C minus C get cancelled, then that is A. Here also A plus B plus C minus A plus C minus C plus A minus A get cancelled, that is B. Here similarly C, B, C, A, C, A, B. This is equal to RHS. Therefore, LHS equal to RHS. Hence, proved the solution of the problem 2 without expanding the determinants. We have to show LHS equal to RHS. This is the most important problem for examination pattern. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.